All right, the purpose of this video is to help you with the worksheet 8.8, which is on exponential growth and decay. And I'm going to specifically pick on numbers 5 and 6 and just do part A there and then leave the rest of that to you. Number 5, if I read this along with you, number 5 says that the tax revenue in a small city receives increases by 3.5% per year. In 1990, the city received $250,000 in tax revenue. Determine the tax revenue in each of the following years, and the first year is 1995. It says that it started out in 5 with a tax revenue of $250,000. That is what we're going to assume be A. Remember, we're doing something A times B to the x power. That is what an exponential growth equation looks like. So the A is the starting amount, and it started with $250,000 in taxes. But then we have to figure out, what are we going to multiply that by? Well, 3.5% as a decimal is 0.035. But we want 100% of this revenue plus that. That means that we want 100% of this plus the 3.5%, which is 103.5%, which as a decimal is going to be 1.035. So in other words, we're going to multiply 250,000 times 1.035, and then we're going to raise that. Like if we wanted, like 1 year from now, we would just multiply it once. But if we wanted it 2 years from now, we'd multiply it by 1.035 twice. In part A, though, they want to know what is the revenue going to be in 1995, which is 5 years after 1990. So we're going to multiply that times 1.035 to the 5th power. On our calculator, it will look like this. We'll have, let me get this so you can see it a little bit here. We will have 250,000. Let me angle it down. Maybe that'll be a little bit better. 250,000. We're going to multiply that times 1.035 to the 5th power. And that gives us $296,921. $296,921 and 50, if we round it up, 58 cents. That is part A. Part B and part C and part D, the only thing that's really going to change is the exponent, because it's going to be that many years after 1990. Hopefully that'll get you started with number 5. If we take a look at number 6, number 6 is a little bit different. 5 is exponential growth because the amount is growing each year. And as you can see from those 5 years, it went from 250,000 to 296,000. Well, number 6 is a little bit different. Number 6 says that suppose the acreage of a forest is decreasing by 2% per year because of development. If there are currently 4,500,000 acres of forest, determine the amount of forest land after each of the following years. So, again, we're going to use this equation, A times B to the x, but we're starting with an amount of 4,500,000 acres of forest. Then we have to figure out, what are we going to multiply that by? Well, because it's decreasing by 2%, if it stayed at 100% every year, this would never change. But it's decreasing by 2%. So 2% is being taken away, which means 98% of the forest remains from 1 year to the next. Well, 98% as a decimal is 0.98. So we're going to multiply 4,500,000 times 0.98. And for part A, it says how much of the forest should be left after 3 years, which means we're going to raise that to the 3rd power. So with our calculators, we will have 4,500,000. We're going to multiply that times 0.8 to the, times 0.98 to the 3rd power. And that's 420. That is 4,235,364. 364 acres left. And you can see that that is decreasing from 4,500,000. So this is part A for number 6, and then the rest for number 6, the exponent is what is going to change. So hopefully that'll get you started with this worksheet. It's all in exponential growth and decay, and we'll go over more of it tomorrow.